Okay, so we will start how to calculate the axial deformation. So here I am assuming a sample. We are applying a force P. Say the cross sectional area is A. So what is my stress? Stress is P over A. Sometimes we use A naught. A naught. Naught means like the initial, the original cross sectional area. So that is the stress. Now, what will be your strain? So after applying some force, this will elongate this side and this side. This side is half delta L by 2, that side delta L by 2. Say our original dimension was L naught. So what is our strain? Strain is delta L divided by L naught. So delta L by 2 this side, delta L by 2 that side, both sides. If I sum up, it is delta L. So strain is delta L by L naught. Now our target is to calculate this. How to calculate this? Okay, so stress, strain. We also know that stress is proportional to strain at the beginning up to the proportional limit. Or we can write this equation this way. Strain is stress divided by E. I believe that you will agree with me that I can write strain stress divided by E. Uh, Now you can see strain is also this equation. So if I insert this value now here, so delta L by L naught. So stress divided by E. Or I can now simplify. If I insert the value of sigma, sigma is here, then I can write somewhere here delta L by L naught P by A naught divided by E. What I did, I just inserted the value of stress. Then delta L is P L naught A naught E. Sometimes we do not write the naught. We do not write it. We want to make it simple. If you do not write it, it means the naught. It means the original dimension. So simply the change in axial dimension is PL by A. So we use this equation directly. Or sometimes P by A, this portion we write by sigma stress, whatever it is. So I believe that you learn how to calculate the axial deformation using this handy equation. So either memorize this equation or note it down or mark it where it is available in your handout or book. Any book will, yeah, some book might use this equation this way. Delta is F L A E. Some, if you use some other book, they might write this way. Same thing. This delta means delta L. Same. F, some book use F means force. I use P. P means force. Why? There is a logic. When you will do steel design in that class, F means stress. F doesn't mean force in that class. So that is why I do not use F for force. But if you use F, it is not a mistake. It's okay. These symbols are not universal. As long as you know it, what you are doing, then it should be good. Okay, now we will see some example how to calculate. So in your handout, you can see that whatever I just discussed, I wrote same thing in your handout. First, what is stress P by A, but A means A naught. Strain is delta L by L. L means L naught. After that, we can derive the equation. You do not need to learn how to derive, just you can use this equation directly. One example here. Can you see this an example? I think yes. Now I am sharing my. Oh, thank you. So this example, a steel bar has a length of 2.5 meter, cross sectional area 200 by 100 millimeter. Yes, unit. You need to be careful about unit. Whatever your unit, your product or the final product will depend on that. Better to be consistent. How consistent? This is meter, this is millimeter. You can convert everything into meter. And then modulus of elasticity 210 giga. I know that, I believe you know what is giga. Giga means 10 to the power 9. 10 to the power 6 is mega. 10 to the power 3 is kilo. 10 to the power 9 is giga. 10 to the power 12 is, I forgot. 10 to the power 12. I don't know. I forgot. But yeah, we never use 10 to the power 12. We use 10 to the power 3, 10 to the power 6, 10 to the power 9. These are the three common numbers we commonly use. Okay, so L 2.5 A we converted into meter and meter. Elasticity Pascal. Pascal means Newton per meter square. If I write down here, what is Pascal? Pascal means Newton per meter square. This is the technical unit. This is the what we call customary unit. In this unit, scientist Pascal, he initially proposed this unit. This is a we name. Say for example, Newton. What is Newton? The name of the scientist, and it is the name of the. It is the unit of force. Now, why unit of force is this? Unit of force is actually kilogram meter per second square, or uh, pound mass times feet per second square. That is the unit of force. But we use this as a customary, like in practice we use this unit. Why? To respect scientist Newton. He developed the concept of force. So to respect him or to carry his name, we use Newton. Same thing for Pascal. Pascal discovered or initially proposed the idea of pressure. Pressure or stress is same thing. So it is force by area square. That is called Pascal. So you should be familiar. I know that you are already familiar with this. So E is 210 10 to the power 9 Pascal. It is given here. Just I omitted G to make the unit consistent. Force is 150 C. You can see it is given as kilo. Kilo. I multiplied by 10 to the power 3. That means 30 to become Newton. Then every unit is consistent. PL by A, P means Newton, meter, meter square, Newton by meter square. The ultimate answer will be in meter. It is very small number, so I multiplied by 1000 to make it millimeter. It now looks better. Even not so good, but it's still better than if you tell somebody the deformation of this material will be 0.0000089. So when you will say 0.000, by this time he will get lost. What is 0.000 means? But if you say 0.089, still though it is not good, but better. 1 millimeter means like the thickness of our nail. Not exactly. Some of you have like thicker nail. My nail say half a millimeter thick, but at least it is a good approximation that the thickness of the nail of an adult is roughly 1 millimeter. It can be slightly more, can be slightly less. At least this is not 1 millimeter. Oh, the tip is 1 millimeter. Yes, good idea. In pen, when we buy pen, it says this one is telling zero point 0.7. 0.7 means 0.7 millimeter. One means yes, you can see the ball. The ball on the top is 0.7 millimeter. Okay, so we are done with one example. Say another example very quickly. Yeah, this example is asking what is the final length. Similar problem, what is the final length? How to calculate? First calculate the change in of yes. So this problem is asking what is the final length. Simply final length is initial length plus the deformation, axial deformation. Then they found the axial deformation first, PL by AE. Here A was not given directly. If you read it, diameter is 0.02 meter, diameter, not the area, diameter. Length is 2.5 meter. Elasticity is given 210. You can memorize this number. It is the modulus of elasticity of steel, always 210 gigapascal or 29,000 KSI, kilo, kilopound per square inch. Whatever the unit is, SI or US, United States customary unit, whatever. Force is given 150. Okay, so length is given. Cross sectional area you have to calculate pi d square by 4. Make sure it is diameter. If it is radius, then pi r square only. Elasticity 10 to the power 9 because it is giga, 10 to the power 9. Force 1000 times 1000, it becomes Newton. So P is Newton, L is meter, A is meter square, E is Newton per meter square. So your product will be in meter. And then they converted into millimeter to make it a good number, because it's very small number nobody can feel. In chapter 1, when I was discussing rounding off, that time I told you there is no, yes, rounding up or significant figures. What is the rule? Actually, there is no rule in engineering. As long as it makes sense, then it is okay. So you have to write in a way that it makes sense. If you report 0.00568 meter to a design, now who uses design? Mainly the field engineer. Yeah, he knows what is fraction. But the labor, if engineers go to lunch, that time the labor might read the drawing. So make sure that all the values make sense. So this value doesn't make sense. But if you express it into millimeter, it makes sense. So that is why we did in millimeter. What is final length? Initial plus delta L. Initial is 2.5 meter, that means time 1000. And then you understood what we did. The main learning here is your unit. What is the unit of different parameter? But everything else is just mathematics. Last example for today. Same, no, same, same problem here. Similar problem, not same, slightly different. A bar 10 meter long, Poisson ratio 0.3. A Poisson ratio given means there is something like something lateral. Poisson ratio is lateral strain divided by axial strain. So there is something new coming. Modulus of elasticity 210 again. Stress is given 200 kilopascal. Is kilo, it is giga. So you have to be consistent. Times 1000 is Pascal, times 10 to the power 9 will be Pascal. If this stress is applied, what will be the change in length? Do we need Poisson ratio? No, I do not think so. Why they give you to maybe too confusing. Sometimes there might be some extra or redundant data, and just to confuse you. I do not think we need it. Okay, why? Let me, if I do not see the solution, how I will solve this problem? Say what is what we know? We know that delta L is P L A E. We know this. P by A is simply or stress. L by E. What is given here? Stress is excuse me. Stress is given here 200 kilopascal. So stress is 200 times this Newton per meter square. What is my L? L is given here 4 meter. What is my E? E is given 210 10 to the power 9 Newton per meter square. So this unit cancels. Then whatever remaining will be in my meter. What will be in change in length? Yes, then we do not need Poisson ratio. Now whatever you will get here, it is in meter. Calculate whatever. Then our final length will be whatever initial plus delta L. Yeah, sometimes we do not write this not. We, like it is not compulsory to write it as long as you know it or as long as you can solve the problem, but it is better to use a popular symbol that everybody uses. So not or L is mean the same thing. Okay, then this you do not need the Poisson ratio. So L naught is going 4 plus whatever you got here, insert it, you'll get in meter. Hopefully this is the question. You do not need Poisson ratio. Yes, they did not use Poisson ratio anywhere. Okay, so we should not go more than this today. Next day we can finish this chapter.